Hello, everyone. So it is August 21st. In your Earth Science in Edmodo, you are going to scroll until you find the post that says 821, Study of Space by Electromagnetic Spectrum. So here we have the link for the reading. We have our practice questions, and we're going to start with the reading. So the electromagnetic spectrum is going to be this whole spectrum of waves. All right. So light is going to be the visible part of this whole spectrum. So astronomers are going to use light and all this other energy contained in the electromagnetic spectrum to gather information about the universe. So light travels at a speed of about 300 million meters per second. All right. So that is actually very fast. It's about 670 million miles per hour. So even though it travels that fast, objects in space are so far away, it's going to take a long time for that light to reach us. So even light from the sun is going to take about 8 minutes to reach Earth. So because the distance in space is so vast, because it's so big, we need a big unit to measure the distances out in space. So this unit is known as the light year. So it's about 9.5 trillion kilometers or 5.9 trillion miles. So this is the distance that light travels in a year. So this is a very huge distance to us, but out in space, this is actually pretty short. So the second closest star to us is going to be Proxima Centauri. All right, the closest star is going to be the sun. Second closest star, Proxima Centauri. So Proxima Centauri is about 4.22 light years away. So light from Proxima Centauri is going to take 4.22 years to reach us. The Milky Way galaxy is about 100,000 light years across. So it's going to take light 100,000 years to travel from one side of the galaxy to the other. All right. So when we see how galaxies look now, we're actually seeing how they look in the past because light takes so long to reach us. So for example, this one called the Whirlpool Galaxy, it's about 23 million light years from Earth. So when we see that image, we're seeing what it looked like 23 million years ago. All right, electromagnetic waves. So light is one type of electromagnetic radiation. So it is a form of energy. It is energy that travels in the form of an electromagnetic wave. So an electromagnetic wave is going to have an electric field and a magnetic field. And each field vibrates up and down, which is going to make the wave. Okay? A few parts you need to know. First is the wavelength. So the wavelength is the distance from one point to the same point on another wave. So it is the distance between two of the same points on the wave. So it can be from crest to crest, as is shown here, or it can be from trough to trough. Trough is the bottom portion, lowest portion. A wave's frequency is going to measure the number of wavelengths that pass a given point every second. So when you get a longer wavelength, frequency is going to be lower. When you get a shorter wavelength, frequency is going to be higher. So now we're getting to the electromagnetic spectrum. Visible light is going to be the part of the electromagnetic spectrum we can see with the unaided eye. Okay, it's going to be all colors, all the colors we know. Each color is going to be determined by its wavelength, and visible light has a range from violet, which is about 400 nanometers, to red, which is about 700 nanometers. So visible light, as you can see, it's a very small portion of this electromagnetic spectrum. So all this radiation exists around us, we just don't see most of it. And the farther to the right you get on here, the hotter the temperature of these energy waves. So ultraviolet, X-ray, and gamma rays are going to be very hot. So make sure that you finish your questions and turn them into me.